Hey everyone, I'm Trent, and in today's video, I want to discuss a couple of concepts that are core to object-oriented programming. Those are the concepts of access modifiers and getters and setters. I'm going to be approaching this from a Python perspective, but they're applicable to any other object-oriented programming language. So I'm going to walk through what those are. So what are access modifiers and getters and setters, why they're important. I'm going to touch on the two different ways you can achieve this functionality in Python, and then discuss the caveats of each method. Throughout, I'm going to be using a practical example to illustrate this. I think that's always helpful, right? And for this video, I'm going to assume that you have some familiarity with object-oriented programming. You don't need to be an expert by any means, right? And I just expect you to know what I mean by the term class and the term attribute. That's about the extent of it. Either way, I hope you enjoy. Let's jump into the code. Great, so to walk through the practical example, let's understand the code first, right? And for this, I've set up a couple of classes that would underpin a application like Todoist or Microsoft To Do, so a to-do list application, right? I've just put together two classes, so task and task list. For illustrative purposes, this is not a complete application. I haven't got a UI or any other functionality. I've simply got these two classes that may form part of a bigger application to illustrate today's topic. So to go through this, keep in mind like a task list type application. I've set up firstly a class over here called task. And under task, pretty simple in its constructor, we've got four attributes. So firstly, we've got a title. So every task should have a name, right? And that's passed through to the constructor when we're creating a task. We give it a title. Then another attribute is an ID, so a unique identifier for each task, because the title may not necessarily be unique, so we need a unique identifier. To do this, I've just cast a UUID4 as a string. If you're unfamiliar with UUIDs, that stands for Universally Unique Identifier. It's basically a really big hexadecimal number that's really unlikely to be repeated. So you can consider or assume that it's going to be universally unique. This is a module directly from base Python, so you don't need to install anything or anything like that. Great, so unique identifier. Then a kind of status over here called isChecked. So is a task checked off or not? It should have two states, right? It can either be done or not done. So I've set by default when you create a task, it is not done, right? That's a fair assumption. So isChecked is false. If it's set to true, we assume that the task has been completed and checked off of a task list. Then finally, every task should have a due date, and this is another attribute that's passed in when we create a task. Great, so that's the basic structure of a task for our application. Now to contain a set of tasks, we have a task list type over here. Let me get some screen real estate. There we go. A task list is, as I said, a container for a set of tasks. So in its constructor, it's got, so this def init thing, it's got a title, so that's passed through as well. So every task list has a title. Every task list also has an ID. So once again, a UUID4 is being used over here. And then a container for our set of tasks is a dictionary. Hopefully it becomes apparent why I'm using a dictionary and not a list. A little confusing there. It's called task list after all. But yeah, I'm using a dictionary to contain all my tasks. The methods, so this class actually has methods. The first one is to be able to add a task. So def add task over here will take a title and due date for a new task. So we create a new task over here using our original class that we went through over here, and then add it to our task dictionary. So self.tasks new task.id. So the key of our dictionary is the UUID for a task, and the value is the task itself. Hopefully that's clear. Then finally, we return the new task ID. So we actually return that value so we can use it later on. Actually, it's really relevant to the next method over here, remove task. This takes in a task ID and will pop that task from the dictionary. So if we wanted to delete a task, so this isn't checking it off or anything like that, it's just removing the task. And so this will do a self.tasks.pop task ID. There's more efficient ways of doing this, right? If if you're familiar with what this is doing, it's just getting rid of this object in the dictionary. That object's reference still exists in memory and has to be garbage collected. So there's better ways of doing it, but hey, this works. Yeah, if none of that made sense to you, that's completely okay. The idea over here is that a task is just getting pulled off of this tasks dictionary over there. Great. Finally, the last method is a show all tasks. This just prints out our task list in a nice readable format. Not necessary for functionality. It's more just for illustrative purposes. But hey, I thought it was quite cool. What we do is we loop through each task in our task dictionary. So specifically the values, and remember the values are the tasks themselves. So we iterate through the tasks. And the status variable is set to incomplete by default. And if the task is checked off, meaning that we have set the is checked attribute to true, the status variable is made complete. That's just for nice formatting or nice printing out over here. So we print out new line task.title, so task name is complete or incomplete with due date, and just grab its due date over there. Cool. So those are two base classes. I've also set up some code here called app.py, and all the script does is play around with our tasks, our task classes, so task and task list. Cool. So to go through how we're just illustrating how this works, the first part over here is setting up a new task list. We're going to call this one work because, well, why not? And then add 3 tasks to it. So you can see we're saving the task IDs over here in variables. So work task list.add task. First, we have a write business report with a due date of Tuesday. I'll come back to why I'm doing that later on. The next 2 tasks actually have dates on them. So explicit dates over here, like the 6th of March 2023. For these kind of exciting sounding tasks, right? Send meeting notes and attend the team meeting. And then I just print out the task dictionary. So work task list.tasks. And over here, I use the show all tasks to print the tasks out in a nice readable format. Over here, I'm using pprint. That just stands for pretty print, if I'm not mistaken. This is built into Python. I just use it to print out dictionaries because it formats them nicely. Instead of like printing them out in a single string, it formats them in a nice readable way on the terminal. Great. Then to show some functionality here, we're going to grab a task. So I've got work task 1 equals work task list.tasks. So that's the dictionary of tasks. And I use the ID to extract it. So this is an actual task type. And then the next line sets its checked value to yes over here, which is technically unexpected behavior. Actually, I'm going to set this to true for now, and I'll set it back to yes and show you why that's a bad idea. So let's just say work task 1 is checked, is true for now. So let's check off our task. And work task list dot show all tasks over here prints out the list of tasks again in a nice format. So to illustrate how this works, let's just go ahead and run our code. So Python app.py, run it. Let's see what we got out. Let's make this bigger over here. And if we take a look at our printout, we've got show work tasks over here. This is a dictionary of these IDs. So once again, these UUIDs appearing, and that's the key, and the value of the dictionary over here is a task object at a certain memory location. So this is what we expect, right? 3 tasks. We added 3 tasks, all going well so far. Then our task write business report is incomplete. So this is the first printout over here before we've checked it off with due date Tuesday, right? and then the tasks and meeting notes is incomplete with due date, right? And yeah, similar idea for the last task. And then we check off the first task, so that's the right business report task. We have changed its is checked value, and over here it says right business report is complete with due date Tuesday, and then the other two are still incomplete. So they're all good, right? Behavior is as expected. Things seem to be working quite nicely. Great. So let's actually get into what this video is about, right? Now, when we use classes, let's think about when we actually use classes from other modules. So for example, I was using UUID before. We have a certain, we have guardrails in place to protect us from using it in the wrong way, right? If we were to use UUID in some strange way, so for example, when I call UUID, if I actually gave it an argument, let's give it a string called foo or something like that, this should throw an error, right? This should stop us from using it in the incorrect way, and tell us that we're doing something wrong explicitly. So if I run my code again, we can see we get a type error over here. So type error, UUID4 takes 0 positional arguments, but 1 was given. So that gives us a hint to say, hey, you're actually using this class in a bad way. You're not meant to give it arguments, get rid of that. So if I get rid of it, run my code again, hey, things are working as expected. So this class, UUID4, actually has guardrails in place to stop us from using it in an unexpected way. Now, we should write our code in the exact same way, right? We should provide guardrails to stop other developers on our team. So let's say we're working in a team, working on this to-do list application. That team member might actually be you. You shouldn't have to worry about like your class's unexpected behavior affecting your code elsewhere. So, and if that developer isn't you, right, it's highly unlikely that someone's going to be intimately familiar with how this class works. I mean, for example, I have no idea how UUID4 works under the hood. I've never read the source code for it, and I don't have to, right? It's well-written code. I use it. It protects me from using it in a bad way or in the unexpected way. So when you're writing code, you should protect other developers using it, using your classes, from making mistakes, right? Or things that are going to give unexpected behavior without them having to go and read all of your source code, right? It should just kind of work out of the box. This is actually tied to a concept in object-oriented programming. It's not exactly the concept, but tied to the concept of encapsulation, which says that your class, every class, should be self-contained or encapsulated, right? Such that its functionality is all held within the class, and it simply does what it needs to do well, right? So it's tied to that. It's not exactly the same, but similar idea. Cool. So let's ask ourselves, given our task and task list classes, what could go wrong? um, we've used it in this app.py. We've messed around with our classes and we've said, hey, things work. It works as expected. I get my printout. Everything's fine. But if we take a step back and consider what could happen if someone else were to use our code, we're not watching them and sitting behind them and saying, hey, use this in this way, actually set this value this way, is check needs to be true or false, something like that, right? So we need to provide those guardrails automatically and, ultimately make our classes better and more secure. Okay, so that gives a bit of justification on the topic. And now I will touch on access modifiers and how they help us in this idea of making our classes functioning well, like making them work pretty well. So the concept of an access modifier pertains or relates to the attributes in a class. Now, you may have seen this if you're familiar with other languages like C# or Java. there are keywords available. So actual keywords in the language that help you set the access modification or access modifier level of your attributes. So if you have no idea about that, all right, let's explain what I actually mean by that. Um, each attribute should have an access modifier level associated with it. I'm going to go through three of them. Other languages, once again, like C Sharp, has more levels. They're a little more complex, but if you're interested, I'll leave some links about that. But the levels that I want to go through are public, so public attributes, protected, protected attributes, and then finally private and private attributes, right? So those three levels are generally what you find in Python, right? So the first level, being public, means that I'm able to access my attribute directly. So by default, in fact, we've been using public attributes the whole time. So in Python, I don't need to specify the access modifier level of my attributes. By default, these are all public. And what that means is I can use, let's say, for example, self.title, so the title attribute, I can use that anywhere I have an instance of task. So anywhere I have a task type, I can access the title and do basically whatever I want with it. I can change it to whatever I want anywhere in the code. So um, let's look at task list. This is actually directly accessing attributes. So in task list over here, we're saying task.title. So we are directly accessing the title. Because it is public, I'm able to get hold of it and I'm able to get a printout of the title over here. So I'd be able to do that anywhere in my code. Anywhere I have task, I can go ahead and access title. As a matter of fact, in its current state, I can access any of its attributes. These are all public. Great. So that's the public level. Basically, no protection on top of our attributes. The next level is protected, right? So this is the next level down. And by definition, a protected attribute is allowed to be used within the class code itself. It shouldn't be used outside of the class code itself. So if I have a protected attribute in task, it shouldn't be used outside of task itself or a child class of task. So if I created another class called subtask that inherited from task, it would also be able to use the protected attributes from task. Kind of confusing, I know, but I'll show you what I mean. So in Python, I say you shouldn't use protected variables or protected attributes, sorry, outside of the class itself, but you technically can. Um, so in Python, the protected access modifier is simply a convention. Whereas in other languages, you have a keyword that where you'd explicitly type. So for example, I could type something like this in C sharp, protected over here, protected self.id. And this would set its access modifier level to protected and enforce that behavior, meaning that someone actually cannot use the ID attribute outside of this class. It wouldn't be allowed. The compiler would throw an error at you. But in Python, it's not, the safety is off, right? You can do that. So in Python, the convention is that your protected attributes should start with an underscore like that. So when you start the attribute name with a underscore, that should indicate to other Python developers who assumably are familiar with the access modifier levels in Python, they should know, hey, this is a protected attribute. I should not use it outside of my outside of the class code itself. Otherwise, I'm going to get unexpected behavior, or I run the risk of getting unexpected behavior. Now, ID is a great example. Why you wouldn't want this used outside or be like you wouldn't want it to be able to be accessed and modified, specifically actually modified. Maybe you want it to be accessed. You don't want it to be modified in a particular way, is because you expect an ID to be a string of UUID4, right? If someone could modify this directly, I've set it as public, and someone assumes that they can set ID to something like the number 1, an integer, or something like that, they can do that. Nothing's stopping them, and you haven't given any warning to say, hey, actually, I handle IDs, or task, the task class handles how IDs are generated. So don't go and touch those, right? Otherwise, funky stuff is going to start happening. So I can set my attribute to protected and say, hey, don't touch this. The only time you would want to touch this is if you're changing stuff in the task class itself or in its child classes. Great, so that's the protected access modifier. The next is private, and this is the most restricted level of access modifier. And private is used only by the class itself and cannot be used by child classes. So even if I created a child class called subtask that inherited from task, it should not use a private attribute. Now, as I said, we have conventions in Python, and the convention for private is actually just another underscore. So, attribute starting with double underscore means private. In later versions of Python, and actually for reference, I am using Python 3.8.8. Sorry, I should have started with that, but hey, got to it eventually. In later versions of Python, this standard of private is enforced. So actually the language does give you a bit of trouble when you try and access a double underscore variable without outside of the class itself. So I'll show you what I mean in a sec. Let's actually go through our attributes and think about the access modifier levels we should have on each. Now, I'm just doing this for illustrative purposes. Technically, if we're following, very strict OOP, we should kind of protect all of our attributes, maybe. Feel free to give me your opinion on that. I'm just going to go through the more obvious cases. So firstly, self.title equals title. I think this is okay if it's public, right? And we should be able to use it outside of the class itself. We want to get the title right. If we have a user interface for our task list application, you should be able to access it and that kind of thing. And these classes outside, like task list, should be able to access it and modify it directly. Opinion, right? For now, maybe there's a better way to approach that. Yeah, we'll actually get on to how to explicitly control this type of thing in a bit. Cool. So we already discussed ID, and I think an ID should be protected. I think that a child class of task should also get the ID attribute. Subtasks, if I think about that example, should also get IDs. So I'm going to go with protected on ID. So just for consistency's sake, I am going to just make sure that wherever I use ID, so I'm just going to do a big find and replace. Oops, left some of my previous find and replace places over there. I'm going to set it to underscore ID wherever ID is used. So let's go and find and replace that. 3 occurrences. Cool. Great. Then the next is checked. I think that is checked should also be protected. Yeah, we want child classes to inherit an is checked value because this is quite, I want to say, essential to what a task is. So is checked should also be protected. So once again, let's go ahead and do is underscore checked and replace all instances of underscore is checked. So just doing a find and replace here in VS Code. Sure, yeah, sure, there we go. Cool. And then finally, due date. Now, should due date be protected? Debatably, if we're going to leave title as public, we can leave due date potentially as public. But we'll return to that. There's arguments for and against that, and we'll touch on it in a bit. So for now, we have set 2 protected variables, and technically we shouldn't be accessing those directly. We shouldn't be using these directly in our code. But we are. For now, we're following very bad practice. Let's assume, we have a developer on our team that maybe doesn't know the standard and is like, okay, cool, let's grab the isChecked value straight from the class. Maybe you just named it something funny. I don't know why. You just kind of said underscore isChecked. I'm going to access it directly, and something like also ID over here. There you go. Uh, you have directly accessing the ID. Cool. So we have that set up, and that hopefully justifies the access modifier idea. Now, we don't have any private attributes, and I don't think we should have private attributes. There's nothing in here that I think should be private for now, but we can get into that, or I can leave that as a exercise to the viewer to think about, what access modifiers they put on top of the attributes in here. I'll actually, if you want to follow along, I'll leave a link to a GitHub repo in the description. Cool. So we've discussed access modifiers, and that should be all good. We've got those three different levels. We have public, which is default, and the usual in Python. You should be familiar with those. Maybe you weren't aware that they're called public or that their access modifier level was public. I certainly wasn't before I was familiar with these concepts. And we discussed protected, which is an underscore attribute name, and then finally private, which is double underscore attribute name. And they kind of go in ascending order of level of strictness. Great, so we've discussed those, and we've discussed that we're actually following some bad practices by doing these, direct kind of calls to them. I shouldn't be using this attribute over here like this. I shouldn't say dot underscore is checked equals true. This underscore should set off some alarm bells in my head. So for now, we have the bad practice going on. Actually, what I want to show you first is if I do something like this. Let's actually take is checked underscore is. So first, let me prove that the code works again. Let's actually make sure that everything's working. Okay, yeah. So you see, this underscore is just a convention, right? It didn't actually prevent me. I didn't get any errors in my code for directly referencing a underscore attribute name. Everything still works, and just to go through it, there you go. Business report is incomplete, and then is set to complete. The due dates look all fine. That's all good. What I wanted to show you quickly is just the behavior you get when you use the double underscore notation in these kind of later versions of Python. So let's change underscore is checked to double underscore is checked. So I'm just running a find and replace in VS Code again. Probably not recommended, right? But hey, there we go. Fast editing there. We've got double underscore is checked, and we're directly referencing it still. Now, if I try and run it, I do get an error, or should get an error. There you go. Right. So attribute error task object has no attribute underscore task list double underscore is checked. So it's seen, well, the Python interpreter has seen that we're using a double underscore here, and it's like, well, this double underscore says that it's private. Private means that this only exists in the context of the class, and it cannot find it. So the class that it's being referenced in over here is task list, and task list has no private variable called is checked, right? So that may be a little confusing, but the point is we get an error when we try and do this double underscore thing over here. So in these later versions of Python, this double underscore standard is the law, right, for private access modifiers. Protected, not so much. Yeah, just wanted to show that. So let's replace everything with our wanted access modifier, which was protected. And yeah, there we go. So let's go ahead and just reset this to defaults, right? Let's clear this output. Don't like this mess. Hmm. Okay, so the that deals with access modifiers. Hopefully, that's clear to you what they mean and how they help you. Now we're going to touch on the concept of getters and setters in object-oriented programming. And as I mentioned, there's two ways to do this in Python. There's the kind of like explicit, kind of feels like a bit of a hack slash convention type of way. And then there's the more Pythonic way. I'll actually do the more Pythonic way first. And while we're going through this, we may change our access modifier levels when we kind of think about them in the context of getters and setters. So let's go through what a getter and setter actually is. You know, the name is pretty descriptive. A getter is a method that is related to an attribute. So a getter helps you get that attribute or controls the way that someone or some system is allowed to get the particular attributes that we're referring to. And the setter, well, you may have guessed it, is how an external system is allowed to set. You have a method that controls how attributes are set if someone else or another system is using your class. Okay, so let's make that a bit more practical. And if we go through how we are in our app.py script over here, which you could think of as a bigger system using our two classes, how it is accessing and modifying data in our classes. So immediately we actually add a task to our task list class, and that's already modifying the dictionary, right, under the task list. So it's already modifying this guy over here. It's adding something to it, and technically this is a kind of a setter already. We've already got a setter, but I'll be more explicit about creating one. We can create one together here. So we're already modifying data, but the one I want to focus on is not so much title. That's okay. You know, we're adding a string title, you know, cool. And then we're adding a due date over here. And its value is Tuesday. Whoops, Tuesday. Whereas the other due dates are explicit date strings in the format of year, month, and day separated by dashes. Now you may think, well, you know, that's pretty intuitive, right? And things seem to work with it. It's like I can say a date is Tuesday. The real problem comes in when you think about functionality. Um, when a user or a system adds the string Tuesday as the due date for a task, do they mean this coming Tuesday? Do they mean last Tuesday or next Tuesday? It's not explicit enough for us to figure out when the due date actually is, right? So to help with this, we're going to use a getter and setter, specifically a setter, to protect a user from making this mistake or what we would consider a mistake. Because semantically, that makes sense. A date can be Tuesday, right? But for the context of our code, we want to get specific, and our task should have a specific due date associated with it. Okay, so let's go through the Pythonic way of setting up a getter and setter. Now, I mentioned before that, you know, due date can be public, no problem. That's all good. But actually, now that we mention it, should we allow someone to directly or indicate to someone, hey, you can set the due date directly, and it's public? And the answer for me is no. Because dates are ambiguous. As I said, someone could consider a date Tuesday or could consider a date in the American standard format, which is like month, day, year, or something like that, instead of year, month, day, which is much better, by the way. But due date is a bit ambiguous. So what I want to do is actually protect this guy. So set this attribute as protected. So now I'm indicating, hey, don't directly access this attribute unless you want things to break, right? So now the problem is we actually need a way to set a due date, and you may want to allow for the functionality for someone to change the due date of a task, right? Things happen. task due dates change, you get extensions, maybe. So we want to allow for that functionality in our application. So we can't just say, hey, this is protected, don't touch it. We need to provide a way for someone to be able to get this value and set this value. So the Pythonic way of doing this is using the following syntax. First, we're going to use this @ symbol. If you're not familiar with the syntax, this is frequently called decorator syntax. That's a bit of a wider topic. I'll probably make a video in the future about decorators. They are very cool, but they're not the point of today's video. So we're going to use this @ symbol at property over here. Okay, no brackets. And decorator syntax is generally, at some decorator and then the method name. So we're going to say at property, and we're going to call this property due date, right? No underscore. Okay. So at property due date over here. I'll give it self because it is a method after all. For now, yeah, I'm going to say return. Let's just go through it now. Return self dot underscore due date. So effectively, this is telling the Python interpreter, hey, this property we're calling due date, no underscore in front of it, associated with the attribute self dot underscore due date. These are now associated with each other. Something more complicated happening under the hood, but you can think about it that way, right? We don't need to understand exactly how it works in the source code. Cool. So now that we've got the property set up, we are going to use decorator syntax again and say at due date, because now due date is a property, due date dot setter. Over here, decorator syntax, no brackets over there. A little annoying that IntelliSense doesn't pick that up, but hey, we deal with what we get. So at due date dot setter, so this is now referring to the property of due date. And we can type def due date again. So we can call it the same thing, right? Normally this would give us trouble in Python, but no problem when we're using property syntax over here. Due date self. And in order to set the due date, we need to give it an argument. So self due date over here. And when we go ahead and do this, we're going to take this, and now let's think about how we actually want to set the due date value. My argument is that we want to use a explicit date time type for the due date instead of a string, but we can still allow a user to give us a string. All we need to do is parse that string to check if it is of a date format that we are comfortable dealing with, and then set up the value. Otherwise, let's throw an error. So when someone tries to use Tuesday, we should throw an error that tells them, hey, that's not a date type. We don't expect that. Instead, we expect something like this. So we're going to, as you try and set that variables or that attribute's value, we're going to parse the string that's given to us. So we're comfortable with user giving us a string, but in our class itself, due date is actually a date time. Cool? Cool. So preemptively at the top here, I've imported the datetime module. This is a standard Python module as well. So from datetime, I've imported datetime and time delta, or I actually don't need time delta for now. So from datetime, import datetime to deal with datetime types. And what we're going to do for the setter value, sorry, there we go. We're going to say self in the setter self dot underscore due date. So my protected attribute is equal to datetime. And from datetime, I want the method strip time. Yeah, so strip time takes in a date string and a particular format and then creates a datetime type in Python. So let's go ahead, get rid of that. And the date string we're going to give it is due date. Whoa, no, that didn't work out well. Due date, yes. And then the format over here. Let's just deal with one format. We'll make it our standard, right? We're going to enforce that the only format we like is year dash month dash day. If you're unfamiliar, that's just how you would format a date in Python. So the percentage sign Y is for year, dash percentage sign M is for month, dash percentage sign D is for day. The dashes are just separators. I could have something like this as well, but yeah, for now we're going to say the only type of string we want to see is year dash month dash day. Everything else, throw an error, we don't recognize that. You could make this more complex to accept other formats, and maybe you could even accept a weekday like Tuesday and assume it is next Tuesday, but we're going to keep things simple here. If you want to go ahead and do that, that could be quite fun to do. Great. So we've got a setter, and yeah, this is good enough for now. And the other thing we need is a getter, because we need to be able to access due date as well to represent it. So dot getter. And for now, I'm actually going to make this pretty trivial. So def due date self over there. And all I'm going to do is say, hey, return whatever the value is of self dot underscore due date. What this allows us to do is, or allows other users of our class to do, is to actually not even think about the fact that due date has an underscore in front of it. They can use the normal syntax of dot due date. So we're actually using that right here. This syntax becomes valid over here, dot due date, without the underscore in front of its name, because this guy is a property. The underlying attribute is protected. This property has explicit control over how things are, over how the underlying attribute is set and gotten, how it is retrieved, and how it is retrieved from a getter perspective, and how it is modified from a setter perspective. That's what the syntax allows us to do, and this is pretty powerful. All right, you are now in complete control over how someone uses your class. So to prove this, let's go ahead and run our code again. Okay, so we're actually still getting Tuesday back, right? So this is a little unexpected. And we will come back to why this is unexpected or why this happens in a sec. Okay, I'm back. I needed to take a quick break. Secretly, it was to figure out why we were getting some unexpected behavior. So when I ran the code, the due date still could have a value of Tuesday. Now, the thing I was forgetting was that I've set up a property, and the property is what needs to be addressed in our task list, or in our task, apologies. So I've been referring to, or in the constructor, I'm setting the value of self.underscore due date, whereas I should be setting the value of the property itself. So there was a little caveat there. I think that due date, technically, the underlying due date should still be protected, but when I'm setting the value, right, I'm able to use this guy. The property is what I should be using in the Pythonic kind of like way of doing this, using this kind of like decorator type syntax. This property is the due date we're going to allow other users, including the class itself, to access directly. So this setup is actually a setter type behavior or a modifier type of behavior on the attribute, right? We're actually setting the value there. And I shouldn't, by doing this, I shouldn't allow someone to pass a due date in to the constructor and thus immediately set due date's value. That's breaking the behavior, right? I'm breaking my own rules, if that makes sense. So apologies for that. This should not have an underscore anymore. The protected self.due date gets created over here associated with the property. So when I ran this before, we still got our problem, which is that we allowed Tuesday to show up in the printed output. What should happen is this. We get a value error. So finally, we've got an error out. We're not allowing Tuesday to be a valid input. And you see we get a nice printout over here to say that value error time data Tuesday does not match the format year dash month dash day. So it immediately tells the user, hey, don't use Tuesday, only use date formats of this format. So we've provided a nice guardrail there to protect us and the user of our class from getting unexpected behavior. So that just helps our class behave in a more intuitive way. Yeah, I hope it's clear what's going on with the attribute over here. You know, this is the property, so this is the thing that I am allowing users of our class to access, this just normal due date. So that's allowed to be accessed publicly because it needs to be, right? We need to be able to set and get due dates. The protected version is this one, the underscore due date, which gets created or is stored over here. And it is a datetime and can be used in the class. So I hope that's clear. Apologies for the confusion there. The first, so now, you know, we get this error and the user of our class goes ahead and says, oh, you know, Tuesday is not the right input. Let's change this to 2023-03-07, which I think is a Tuesday. So valid input there. And if we run it again, we can see we get a printout, but our dates look a little different. So task business report is incomplete with due date, and now it's the date followed by a timestamp as well. Right, so everything works. This is as expected, but generally you don't want this kind of like timestamp on top of the date stamp. It just makes it look a little ugly, and you know, it may not be what's wanted. We don't want an exact time to be presented to us. Maybe we do, and this is fine, but let's assume that we don't. The problem here is probably, as you guessed it, is the getter, right? So over here where we print it out, this is getting the due date, this public version of the due date, which is a property in this class. And the getter just returns self._due date, which is a timestamp. And so when you try and convert that into a string, it gives you a string that looks like this at the bottom here. This date followed by a timestamp defaulted to midnight. So if we don't want that behavior, assume that we don't, we need to change our getter. And for our getter, we can once again turn to our friend datetime, say datetime, and convert our datetime back into a string. So we're going to say datetime dot strip time this time around. Sorry, lots of time there. Datetime and the first argument. Okay, so this is the syntax I prefer, but there's another way to do this, but I'm just going to follow the syntax I'm familiar with. Actually, I believe we should use it this way. Apologies. So self._due date, which is a datetime, and say strip time to it and give it a format. Okay, let's just use our usual format. So this should be year-month-day. Actually, you know, just to illustrate the power of getters, you know, I can manipulate how the date is gotten. I'm going to say when I return this back to a user, which is kind of weird to say, but like when I return this back to the user, I want it to be have slashes in between. And so if I do that and I say Python run app, oh, you can see I even made a mistake here with the month part. But you can see it's printing it out in the format that I'm specifying now that it's getting it, right? So there, it's appearing with slashes. That's a bit weird though, so I'm going to stick with dashes. I just wanted to show you that it will print it out. If we change the getter, right, it's actually changing the get behavior. Cool. Great. So there you go. You now have provided some guardrails over the due date because it's a bit ambiguous. You've provided a public attribute that is underpinned by a protected attribute that controls how to get and set due dates, and it prevents unexpected behavior like users of your class inputting a string of Tuesday into your due date. Cool. So that's super powerful, and that's the Pythonic way to do it, the recommended way to do it in Python. When I say recommended, I think PEP 8 recommends this, but there is another way, and it's a more explicit way that is probably more familiar to people who have a background in C# or Java. And that is to actually go ahead and write your own getters and setter methods without using this property syntax. So to illustrate this example, let's go through the other problem we have, which is this is checked guy over here. So once again, we have a protected attribute over here. It is being directly accessed, so already a no-no. And just to show you what could go wrong by allowing someone to directly access the isCheck value is, let's say the user thinks that this should have the value of yes. That makes sense to them. You know, is checked is yes or no. Hey, that works. Cool. Let's run the code and see what happens. Okay. So if I take a look at the output, you know, usual output, we've got our dictionary output. We've got our 3 tasks. Awesome with the due dates. But then when we check off the work task, write business report is still incomplete, whereas we expect it to be complete, right? We're meant to check off a work task in our code. Why does that happen? Well, in our show all tasks logic over here, we are saying if task.isChecked is true, then set it to complete. Otherwise, keep it as incomplete. And well, we passed it in the string yes, and it turns out the string yes is not the same value as the Boolean true, and so the status remains as incomplete. This is a very troublesome bug, right? Because it is one that passed right under our noses. Our code ran, no error was thrown, and so we are stuck with a bug that could persist for a while. You know, layers of code is going to be added on top of our to-do list application, and then later on, a whole bunch of debugging work has to be done to trace it down to this problem. The fact that is checked is being accessed directly. Cool. So hopefully that legitimizes why that's a problem to you. And let's fix it, not by using the Pythonic way, the implicit way, to change the access and modification or getter and setter behavior. Let's do it the explicit way. Now, you could do it the implicit way. There's no problem. Actually, you know, that would work quite nicely. But you just rinse and repeat the same process as you did with due date. But I just want to illustrate that you can do it another way. And this way is actually a lot simpler. You would literally write a method called def. Let's start with set is checked, right? No decorator, nothing like that. Self, and you can say something like, let's just call it value. Actually, yeah, let's just call it value. That's fine. I'm going to say pass for now. So we've got a setter, an explicit setter, and now we've got def get is checked. Self, no value needed, right? Because we're only getting stuff, not changing stuff. Cool. Set is checked, get is checked. Let me close this. 2 explicit methods for setting and getting this value. We've indicated that it is protected, saying that, hey, you know, don't directly access this attribute. We are going to give you methods to be able to do what you want to do with that attribute, but we're going to be in control over it. So for set is checked, what we're going to do is we're going to allow someone to, or a user to pass a value into our set is checked method over here. But what we want to do is check if it is a Boolean or not. If it is not a Boolean, we're going to throw an error. If it is a Boolean, no problem. So to do that, we can use the Python keyword, well, first an if statement, and then say if is instance value, so that's value, is instance of type bool. So this basically says if value is a bool type, then pass, right? So actually, let's deal with the, yeah, actually, I'm okay with doing it this way. If is instance value bool, then we're going to say self dot is checked equals value, right? So we've checked if it's a Boolean, if it's a valid Boolean, so it's true or false. We can hand it over to the protected attribute. We're using this in our class, so we're obeying the rules. Self.isChecked equals that value. And if that's not the case, we can be explicit and say else. You want to raise an exception, but I think exception handling is the topic of another video. We'll get into that in another video. So for now, I'm just going to print a message. If you know about exception handling, feel free to add a raise an exception here. But for now, I'm just going to say we're going to give it a message like value is not a Boolean type exclamation point, because let's be aggressive about it, right? Or now let's be nicer, full stops. Cool. So if it's a Boolean, no problem, set the value. Else, if it is not a Boolean, so that's the else part of this, then print out, say, that value that is not a Boolean type, but should be, right? So there we go. We've handled the explicit setter, set is checked. Now let's handle the explicit getter over here. And all this needs to do is literally just say return self dot is checked. A nice idea may be to get the is checked value as incomplete or complete. So actually taking this little stub of code and using it on the getter. But I'm going to stick to just returning the bool value. Yeah, that could be like nice functionality to add to the getter, maybe. Right? So now that we've done that, if we are in a team and we've said, hey, you know what, our standard is to have setters and getters, do not use this syntax. I mean, do not use this attribute because it is protected. That's what the syntax tells us. In our code, all we need to do is say task.get is checked over here, is checked. Over there, yep, we run that. So task.get is checked, that'll get the value back, check if it's true over there. Is there anywhere else we use this guy? Nope, I think we're good. The other place is here. I'm actually going to leave this. No, wait, sorry. I'm not going to leave this, right? We shouldn't be doing that. We're going to say task1.set is checked. And the value we're going to give it for now is still yes. So let's assume that the user of this class is going to say set is checked, and to them, yes, makes sense. Let's see what happens when we run the code like this. There we go. So we didn't raise an error, so printouts still happen. If we were doing exception handling, this wouldn't, we would stop the show. But you can see over here we do get that printout value. Yes, is not a Boolean type over there. So we're just printing that out. Technically, you should you should halt the whole show. So maybe like I said, we'll get into exception handling in another video. Let's leave it at that for now. But yeah, we're saying, hey, look, value yes is not a Boolean type. That's not allowed. Let's not do that. So that indicates to the user, hey, let's instead set this to a Boolean, and we want it to be true, and run it. And there you go. Functionality is back. Task write business report is incomplete here. Yet when we check off the work task, its status is now complete. Great. So yeah, this is the second way to go ahead and do access modifiers. The more basic, almost feels like a hack way, but in some ways it can be better. So for the final part of this video, and if you're still with me, thank you. I appreciate the dedication. I respect that. The final part of the video, we're going to discuss caveats of these two methods over here, or these two ways to go ahead and control access and modification of your class attributes. I want to actually make a note, sorry, about this first. The note is that, in this case, when you've got a value coming through your constructor, the explicit way requires you to do something like this. Let's say that we wanted to create the is checked protected attribute, but we required someone to pass it through here, is checked over here. So you had to pass the value in the constructor. How you would do that is say self.isChecked, all that, and all you need to do is say self.setIsChecked, and then pass it is checked like that. oops, is checked like that. And this would work. So just to be explicit, if let's just test it out and prove it. So there you go, is checked. By default, it's false. But otherwise, let's give it a value there. So let's run our code. Everything still works. And the behavior is as expected. Incomplete, check off the task, it's complete. Nice. So that handles it. I just wanted to make sure that I cover this. It can be a little confusing. In the past, I've done something like this and then gotten an error and been like, why does that happen? You have to say self.method, right? Which now that I think about it is a little obvious, but hey, I just wanted to cover it, make sure that you are equipped with the knowledge. Cool. But I don't want to do that. We should not give the option, in my opinion, to give the isChecked value in the constructor. Cool. Fantastic. Okay, so that covers, we've covered access modifiers. We have covered getters and setters. You may argue that, hey, there's other places we could change the access modifiers or getters and setters in this, even in these two simple classes. There's other things we can do. Hey, what about the tasks? You know what I mean? Should you be able to access that directly? Should you be able to set it directly? Probably not. But I'm not going to cover that. I've illustrated the point. I'll leave it as an exercise to viewer if you want to go ahead and figure out, hey, how should I protect this tasks container? That's a little more complex. So yeah, there's a challenge to you. The last thing that I wanted to cover was just the caveats between the two, or comparison, I suppose you could say, between the two different ways of doing this. And I'm going to start with just some semantics. Always good, right? So this first Pythonic way, the way we did this for due date, this is somewhat cleaner, like it looks nicer in my opinion, but it does add, this kind of like overhead of having, multiple extra methods and stuff in your class. But when someone uses it, they don't have to care about the access modifier. They don't have to say, hey, this is protected. I probably shouldn't use that. Hey, let me go and search for a setter and getter for this thing to make sure I'm using it in the correct way. They just use it as they normally would. They just use it like this task.dueDate and things work magically, right? The thing though is that hides a lot from the developers, and maybe the developers in your team are, perhaps you're working on a project and the developers are more familiar with C#. They've never written Python before, so they're actually used to doing this. This is more akin to C# or Java. So perhaps it may be a better choice for your team to use this, to agree on this as the standard for getters and setters on your project. It makes a bit more sense to people from other backgrounds. This is very specific to Python. And also, like I said, hides a bit of what's going on from the developer using your code. I mean, if that's what you want, if you want that hidden kind of behavior, which is, generally what happens in Python, then, by all means, go ahead and use this method. One of the other kind of caveats that I want to discuss is a bit more on the functional side, so not so much team standards or anything like that. And it's to do with inheritance. Now, if you were to create a subclass for task, a child class, sorry, and task was the parent class, let's call it subtask, you would inherit the entire property using this syntax, meaning that this entire property gets passed down to the child class, which may not be the expected behavior because you may want to override the getter and setter behavior. So you may want to slightly change how due dates appear in, let's say, a subtask. Maybe you want it to be printed out as like a day of the week or something like that, or just a month, something, some kind of requirement like that. And that's not easy to do when you inherit from a task, or it's near impossible to override. It's impossible to override just a getter or setter. You inherit this whole bit of functionality and cannot change it in the child class. It needs to behave in the exact same way as in the parent class. Whereas with this explicit kind of way of doing things. Of course, you can override it. These are just plain old methods. They're not a property or anything special like that. They're just vanilla methods. You can override them as you wish. So that's just something to consider. And that's a bit more of an advanced kind of like topic. But yeah, just as a fair warning, if you're planning to use this in your own code. Great. So this video came out much longer than I expected, but I had a lot of fun making it. I hope you take something out of this video, something useful. Um, if you did, that means a lot to me. And as I said, this is always fun for me to do. So yeah, I hope you enjoyed, and I will see you soon.